Hello everybody and welcome to chapter 6, which is basically on arrays. We already have introduced arrays a few lectures before this one, so we're going to quickly recap some of the basics and then move on to topics that we haven't covered before. And we've already studied that arrays are data structures consisting of related data items of the same type, and these are static entities that remain the same size throughout the program execution. So once you've initialized them, you cannot change their size. It's a group of contiguous memory locations that all have the same type, and to refer to any particular location or element of an array, we have to specify the name of the array, just as we would refer to a variable. Then we have to follow that up with square brackets, and then in those square brackets we need to specify the position number of the particular element that we are talking about. The index or the position number for an array generally starts with 0, and we looked at this example in the previous lectures. We said the first element of the array starts at 0. Position number is referred to, or is also called the index or subscript. Index is the term that I'm going to be using throughout my lectures, and to refer to the position or an index, you can write either the index explicitly. So this refers to the element which is at index number 11 of the array C. Another way of specifying the index or the position is to write down an expression that evaluates to an integer, and that can also be used. So in this case, if A is 5 and B is 6, then we will be referring to element at index 11. Okay, and we've already discussed how to define arrays, and we're going to be looking at some more ways of defining them in more detail today. And so today we're going to start off with defining an array using a loop to set its elements, and we can do that, or we're often required to do that. Say we have a large array, rather than setting each individual element of the array one by one using multiple equality or assignment type of statements. What we can do is access the elements of an array one by one using a loop, and then use that loop to assign some of the values. So let's look at an example of this. So we have a program here where we basically first start off with an array called n, which has size 5. So it has 5 memory locations of type int that we need to assign values to. So how can we do that? Well, one way of doing that is to take a loop and start that loop, for loop at 0, take it up to 4. So this loop goes up to 5 minus 1, which is 4, because this is less than 5, not less than equal to 5. And we're going up to 4 because, again, since index number starts at 0, that means that element number 5 will be located at index number I equal to 4. And so how does this program work? Well, we have at each iteration of the loop, we write this statement: n square brackets I is equal to 0. So what that does is, at the first iteration of the loop, I is basically equal to 0. So we get n 0 is equal to 0. So this is the statement which is executed. Similarly, at the second iteration, we get n1, that is also set equal to 0, and then we keep going until we get to I equal to 4. Sorry, this looks like a y, but this is actually 4. So then we get to the final one. So this is the way that this program works. Now, one thing that you might have noticed here is that instead of using a variable of type int or unsigned int, we are using something called size underscore t. Now, what is size underscore t? That is a new type of data type which was kind of which came about recently, maybe around the early 2000s, and this was basically invented or created as an afterthought, because if you want to access very large arrays, then sometimes the existing data types are not enough to access, or they don't support a large enough number of index. So size t was basically added later, so you could access arrays which were much larger in size. So in this case, it doesn't really matter, because we only have an array of size 5, but let's say if we had an array of very large size, then size underscore t actually helps us with that. So this is what we're using. So now, once we have all the elements and they've been set to 0, so all elements in our array are set to 0, then what we can do is also print them. So we have a printf statement which first prints the strings, element and value, and then we basically have another loop which again starts from I is to 0, goes up to I is equal to 4, and what does it do? It prints I, and then it prints the value of the array n at index I. So let's look at that. So we have element 0, element 1 is also equal to 0, element 0 is 0, element 2 is also equal to 0, array element 3 and 4 all are equal to 0. And so in general, when you're working with arrays, what you'll need to do is a lot of the times use one for loop to set the values to something, and then if you want to print the values or a subset of values, then you will need to use another for loop to print those out. And here we're talking about the size t type of data, which kind of represents an unsigned integral type, and this is generally the one which is recommended for any variable that represents an array's size or indices. So this is the sort of variable that you should be using when you want to access or define the size of array elements. And if you want to use size underscore t, then you need to include the stdf.h header file. So you have to include over here, and even though it's not included, but you have to include stdf .h over here. Okay. The next concept that we're going to cover is initializing an array using a different technique, which is basically using an initializer list. And you don't really have to use a loop to set the values or assign values to elements inside arrays. You can also have what is called an initializer list, and we'll see what that is in a second. But the initializer list basically uses curly braces. So let's look at an example of that. And here is the initializer list. So one way that we could have assigned elements values to the elements of this array is to use this this type of a command, where we can basically use curly braces, and then in these curly braces we are defining the 5 values. So 32 basically is the first value, which is at index 0, 27 is the second value, which is at index 1, and then so on and so forth, and the final one is equal to 95. So this is another way that you could basically initialize an array. And then again, if you want to print this, you can print the elements of the array using a for loop, and let's see what that is. So yep, so you can see that element 0 has a value of 32, element 1 has a value of 27, 2 has a value of 64, 3 has a value of 18, and then 4 has a value of 95. So makes sense. And sometimes, and in fact a lot of the times, what you want to do is to set all the values of an array to 0. And this you can do by this kind of a statement. So if you put inside curly braces just one value, what that is going to do is it's going to assign 0 or whatever value you have here to all elements of the array. So in this case you have an array of size 10, and all the elements inside that array are initialized to 0. And so in this case what happens is the first element is initialized to 0, and then the remaining 9 are also initialized to 0, because we did not specify initializers for these. But it's kind of important to remember that arrays are not automatically initialized to 0. So you must at least initialize the first element to 0 for the remaining elements to be automatically zeroed. Okay. And something that you should not forget to do is to initialize the elements of an array. Okay, this is something that you need to do. And one more thing, that if you obviously specify the size of the array to be 5, but then you try to add 6 elements, or you initialize it to an array of size 6, so 1, 2, 3, 4, 5 and then 6, then that will cause a syntax error, because the program is expecting an array to be initialized to something which is of size 6, size 5, but you are over here giving it 5. So this is something which will result in a syntax error. However, if you do not want to, another way to specify or initialize an array is to not specify or omit the array size from the definition. And if you omit the size of the array from the definition, so in this case we have not really specified any size here in this particular example. So this basically is just blank. Now in this case, what the compiler will do is it will take a look at the number of elements that are inside the initializer list, and it sees that it has 5 elements there. So what it's going to do is it's going to create an array whose size is 5. So in this case, you don't really need to specify the size. So this is something that also you can do. But if you've specified the size here, then the number of elements that you specify over here cannot be greater than the size of the array. I think if you used a smaller number of elements, maybe 4, then it would work. But if you try to add more elements than the size, then that will result in a syntax error. Now, one more thing which is very useful practically is to use a symbolic constant to specify the size of an array. So rather than actually writing a number, you basically use a symbolic constant to initialize the size of arrays, and this is something which is practically very useful, and I'll show you that why it's important in the next example. So what are we doing here? So the first thing that we're doing is we are using a symbolic constant which is written like this. So you write hashtag or hash define, and then you write the name of the constant, and then you write the number that it is going to replace. So this, and then remember there is no semicolon here, so do not put a semicolon here. And what this will do is symbolic constant size, what it will do is it everywhere in the program where it sees this particular symbol, capital SIZE, size, it will replace that with whatever follows it. Okay, so wherever in the program it sees size, it will replace that with 5. So we define the size to be 5, which obviously gives you a hint. The size of our array is going to be equal to 5. Okay, so next we go into our program, and then inside our program we write int s, and then in the square brackets we write size, which means that our program is going to replace this with the number 5. So this is 5, and then here again when you are actually initializing the array to some numbers, what that will do is again this one will also be replaced with 5. So you basically are going from j is equal to 0 to j is less than 5, and then at every index you are assigning whatever value is evaluated by this expression. And then here again you also have size. So when you want to print the elements of the array, well again this size over here is going to be replaced by 5. And so again you're going to print the values that you assigned to the elements of the array. And so why is this useful? Why is this practically useful? Well, notice that let's say you change your mind and you want to instead of using a size 5, you want to use size 6. Well, you can just simply change that here, and you only have to change it once. Now if you were not using this symbolic constant, then you would have to change 5 to 6 at this location, at this location, and also at this location. So you would have to change it at 3 places. But if you use a symbolic constant, then you do not have to, you only have to change it at one location and not at 3 different locations. So this saves you some time and effort and a bit of headache as well, because let's say you are doing it multiple times. If you are accessing this array multiple times, let's say you were accessing, maybe printing it 5 times or changing the value 2 times. So this maybe you have 7 for loops in your program. Now, if you try to change the size manually, and out of those 7 locations, 7 for loops, let's say you forget to change the size in 2 of them, then that is something which can cause problems in your program. So that's why to specify the size of an array generally is recommended to use these kind of constants. You could also assign the size by maybe writing using a variable here, but again that variable needs to be a constant type of variable. It cannot be a variable whose value can be changed, and I'll show you an illustration of this when I actually run this program in the IDE. So here you again see, so you have element number 0 which is equal to 2, element number 1 which is 4, and then so on and so forth. And why is this? Well, let's see. At j is 0, you get 2. At j is 2, you get 2 plus 2 times 1, which is 2 times 1, and then 2 that gets added to 2, so that's 4. So the values that you see here are 2, 4, 6, 8, and then 10. Right, so what did we do? Well, we used the preprocessor directive define, #define. Sorry, this is here, and then we use that to define the size. Basically is the symbolic constant size whose value is 5, and so what it does, it replaces everywhere it sees the symbol size or this expression or this name size, it replaces that with the number 5. Now remember that do not put a semicolon after 5, because if you put a semicolon after 5, what it will do is when it is evaluating the array expressions, what it will do is instead of size s being equal to 5, what it will do is it will write something like 5 and then semicolon. So that's why you have to remember, do not put a semicolon after at the end of a symbolic constant. Yep, and so this is what it's saying. Do not use a semicolon at the end, because preprocessor directives are not C statements, so you basically should not be putting a semicolon at the end of those. And the advantage of this is that it makes your program more modifiable or easy to modify versus the case when you're not using them. And also remember, use only uppercase letters for symbolic constants, because this is also something that is recommended. If you have multi-word constant names, then you can separate them by underscores. So if you had multiple arrays in your program, let's say you had array A and array B, well, you could use the size underscore A to specify the size of array A, and then maybe size underscore B to specify the size of another array which might be called B. Okay, so the next example that we're going to look, and then again this is a classic example, and this is something that is used in a lot of programs. In fact, in a lot of real life practical situations, this is something that actually is needed, and that is summing the values of the elements of the array. So in this program, the next example, what we're going to do is we have an array of size 12. Is going to have some values, and what this program is going to do, it's going to add all the values of the array together. So the first thing that we have is a preprocessor directive which tells us the size of the array. Then we initialize the array to these values using the curly braces. And so if we want to sum all the values in this array, and you've seen some type of programs previously, what you can do is initialize a variable. You could call it total and set its initial value to be 0. You could also call it sum and set it to 0. And then what you can do is browse through your array. So walk through your array through all the elements one by one. So start at index 0, go to the final index, which is 1 less than the size, and then at every iteration of the loop, what you're doing is you are accumulating the values. So you are adding the current value of the array, so the value of the array at the current index I, you're taking that and you're adding that to the variable total. So the first time you're going to get total plus which is 0 plus the first value which is 1, and then the second time you're going to, when you go through this loop, you already have 1 in there, you're going to add 3 to it, and then that's how you keep going, and this will basically give you the sum of the array elements, which in this case is 383, and you can check whether this is actually the case. So this is another thing which you often will have to do when you are working with arrays. Now let's look at a slightly more complicated program, and in this program what we're going to do is we're going to count the number of occurrences that we have of each type of value. So what does this program do? Well, this program, what basically it does is it simulates a student survey, and in the student survey what we are doing is we have asked students to rate the quality of the food in their cafeteria on a score of a scale of 1 to 10. 1 being that they're very unsatisfied or unhappy with the quality of food they're getting, and 10 being that they're very happy with the quality of food that they're getting. And so what we want to do in this program is we have 40 responses from students. So in this case we have those responses inside an array whose called responses, the size of which is represented by this constant, responses size. The size is actually 40, so we have 40 responses here. So first student gave a rating of 1, the second one gave 2, the third one gave 6. And so what we want to do in this program is to count the number of times or the number of students who gave 1, and count the number of students that gave 2, and then count the number of students that gave 3, and then go on, keep going until we get to 10. So we basically want to count the number of occurrences or the frequency of each of these integers from 1 to 10. Okay, so this is our responses array. So it kind of contains the results of our survey, right? And so we put that here. The second array that we have, which is going to allow us to count the number of values that we have. So the number of ones that we have, it's going to tell us, okay, maybe 3 people gave a 1, and then maybe 2 people gave 2, and then so on and so forth. So this is going to be basically contained inside an array which we are referring to as, or calling, frequency. The size of this is represented by frequency size, and we're setting all values to be equal to 0 initially. So we're initializing the whole array to be equal to 0. Now the size of this array is 11. Now you would think that this should be 10, and yeah, I mean it should be 10, but it will actually be a lot easier to write this program if you use 11 instead of 10. So if you ignore 0 and then look at the indices from 1 up to index number 10. Index number 10 is basically the 11th element of this array, and you basically store the counts of each number inside the index of this frequency array. So index number 1 will contain the number of counts of number 1, so how many times did number 1 occur. Index number 2 will count how many times did the number 2 occur, and then index 10 will count how many times did the number 10 occur. So this is more natural than using 0 to 9, because that would be a bit more complicated. You can do it, but it would make the program more complicated, and so since there are no zeros, we're really going to ignore this value. So all these values are initially set to 0, and then once all these values are initially set to 0, what we can do is loop through our program. So loop through our responses array, which is this one here, and every time we see a number, we basically increment the index that corresponds to that number inside the frequency array by 1. Okay, so let's look at this. So we have this for loop here, which uses answer from 0 to response size, which is 40. So we basically are going through our responses array whose size is 40, and every time so let's look at answer number 1. So answer number 1 is this one here. So we have we're looking at responses sorry for the bad handwriting, I'm writing with the mouse. So answer number 0 basically contains 1, and so the first student basically gave a rating of 1 in his feedback, and then what we do is we basically take this 1 and we increment the value of the frequency index index 1 by 1. So we basically increase that. So it was originally it was 0, then we increase that to 1. Similarly, when we get to the second element, that one contains 2, so we're going to increment the index of the frequency array at 2. Then when we get to the third one, this student gave a rating of 6, so we're going to increment the frequency array. We're going to increment the value at index 6 by 1. So we're going to increase its value by 1. So that's how this program works. Let's look at the output. So you see that two students gave a rating of 1, 2 students gave a rating of 2, 2 students gave a rating of 3, 2 students gave a rating of 4, 5 students gave a rating of 5 and 11 students gave a rating of 11, and you can see for 7, 8, 9 and 10 as well. So this is the sort of response that you would expect. So most people, or the majority of the people, kind of gave a slightly average or above average rating. And so over here in this part of the program, we are just printing the rating and the corresponding frequency counts that we got. Okay, and this is just an explanation of the program that I have already done. This is again the explanation. Now one more thing which is kind of important to remember is that C has no array bounds checking to prevent the program from referring to an element that does not exist. So let's say if you have an array, let's say we had the array frequency and the size of that array was 11, so we could go up to index number 10, but let's say at some point in our program we got into a situation where we were referring to frequency index number 15. Now C really has no way of checking whether whatever is at index number 15 actually is part of the array or not, right? So it will not check this. It will only check the size initially when you actually run the program, but after that, let's say after specifying a size of 10, you try to add something or access the value at this index which is not really, or which is beyond the array boundary. This is called, basically you will walk off the size of the array, so the boundary of the array. So if your array is this size, so it goes up to this particular location, it has maybe so 11 elements, index number 10, but now whatever is here will probably not be part of your program. So but your program will still go, if you ask it to go to index number 15, it will still go there and print out something else which might be part of another program, and this is something which you should be really careful about and avoid, or do your best to avoid. And why is this? Because this is a security issue, and it will cause your program to actually compromise the security of your data, because whatever is at this location which is not part of the array will belong to another program, and that is something that you really should not be doing. So to always ensure that all array references remain within the bounds of the array. Finally, one more thing that we're going to do is graph the elements with histograms. So counting the occurrences of unique elements, just like we did with the previous case. So we had 10 numbers and we were counting their frequency. This is something which is generally called a histogram. And the histogram example is also very important. Histograms are very important in probability related problems, and so we're going to look at or revisit the random number example that we did a few lectures ago, and what we're doing is okay, just one second. So in this case we have an array element, so array which is of size 5, and it kind of contains counts at different indices. So first one is 19, second one is 15, third one is 7, fourth one is 7, fifth one is 11. So you could think of this as, element 0 or the number 0 was seen 19 times, the number 1 was seen 3 times, and so on and so forth. Now this is something which is called a histogram, and you can print this by first going into this array. So you go into into this array, and the first thing that you do is you have 5 elements. So you go here, and the first thing that you do is you basically print the index number and the value at the index number. So the first thing you're going to print is 0 and then 19, and then after that you're going to use a for loop to print asterisks equal to the number contained at that location. So the first time you're going to print 19 stars, second time you're going to print 3 asterisks, and this basically gives you a histogram. So element number 0 occurs 19 times, and then the histogram basically contains 19 stars. Element number 1 occurs 3 times, and the histogram basically has 3 stars. So this is just what a histogram is. Now this is important in probability type of problems. So if you look at this one, if you go back to our rolling a die example, we were rolling the die where 60 million times and summarizing the results. So we were counting how many times did the numbers 1 to 6 occur. So if we roll a die 60 million times, how many times do we see 1, how many times do we see 2, and so on. So we can take that program and modify it a little bit. So we roll our die 60 million times, and at every time that we roll the die, we basically count or increase the count of the number that comes out on top, represented by the face variable. And so at the end of our program, we're basically going to have a histogram or count of the frequency. So we have the number 1 occurred close to 1 million times, the number 2 also occurred close to, not million but 10 million, and so on and so forth. So we will look at this in more detail when we look at the this program in the Visual Studio hands-on part.